What's good, you guys? It's Justin, and we're going to be going over the mirror problem in Ms. Bouget's, from Ms. Bouget's Period 6 Physics Honors class. So, before we start, I just want to give a big thanks to my group, Chelsea, Matt, Brian, and Kyle, for helping me understand this problem because this was a doozy. So, yeah, the problem was how big what's the size of the mirror need to be in order for you to see your entire body image from head to toe. So this is going to be our mirror right now, our this blue line right here, and this red line will serve as our wall. But obviously the mirror could be hanging. Like you don't necessarily need a wall, but you do need something to hang the mirror on, of course. So anyway, this is going to be our line of reflection for our foot. So our foot's going to shoot a beam of light. Well, not really, but you know what I mean. So our foot's going to hit the mirror and it's going to reflect back to our eye. Now we know that the angle of reflection, so this distance right here and this distance right here will be the same because it's your reflection. So we know those two will be the same. And we also know that these two are the same because um, as the angle of reflection will be angle in, angle out. So these two angles right here will be the same. And then we know that these two are 90-degree angles because this would be a straight line, so 90-degree angle, and this would be a 90-degree angle. And then we know that this distance right here is the same as this distance right here because as long as you're standing up straight, obviously your distance from the mirror, from your head, and then also from your foot would be the same. So we know that these two triangles are actually congruent. I know it doesn't really look that way because my drawing is terrible, but yes, these are congruent triangles. So we can safely say that this distance and this distance are both A. We'll say they're both A, and then we know that this is A. Now, here's the cool part. We also know that this angle right here from this line by the way is going to serve as our height. So right there. And then this line will also serve as our height. So we also know that the angle of your height as well as the angle of your foot to the mirror is going to be the same as this angle right here. So how do we know that? Well, I don't want to be drawing parallel lines because I think there's enough lines on the screen, but we do know that this angle right here is going to be congruent to this angle because they are vertical angles. So since we know that this angle is congruent to this angle, we can say that they're congruent. And assuming you're standing up straight and the mirror is not at a tilt or anything, these two lines right here and here are going to be parallel. So because they're parallel, we know that alternate interior angles, there we go, I got it. Alternate interior angles are congruent. So we know that this angle is actually equal to this angle. So therefore, this angle right here and this angle is going to be congruent. So we know that those two angles are congruent, and the same thing applies to up here. This is the line from our head to the mirror and reflecting back to our eye, and then same thing on this side. And then this line right here is just the line from our head to our head. So we can actually get rid of this line to be honest, but just know that this angle right here is the same as this angle because once again they're vertical angles and then they're parallel lines, alternate interior angles. So this angle is congruent to this angle, which is congruent to this angle. So now that we've established that this angle is congruent to this angle, and same thing with this, and we also know that this angle is the same because, not the same as these angles, I mean, there are two different triangles here. There's one triangle right here, and then there's a really big triangle right here. So this angle is the same for both of those triangles if you look at it. Now, obviously, the drawing is not as good because I'm terrible at drawing diagrams, but we know that this angle is congruent to itself, obviously. So we can safely say that since all three angles of the triangles are congruent, they are similar triangles. So because they're similar triangles, we know that similar triangles have proportionate sides, right? So since we've already established that this length is A and this length is A, we can say that the length of this bigger triangle is 2A. Now, we're trying to find x right here, which is the size of the mirror. So, our final proportion will be x over h is equal to 2a over a. So x is the size of the mirror, h is going to be our height, and the a's are the distance from your foot to the mirror, like in this case right here. Yeah. So that is our proportion. So that actually means 2a over a, if you just cross out the a's, it'll just give you 1/2. So, oh, I'm sorry, this is the wrong proportion. Ugh. This is actually a over 2a. My bad, guys. I gave you the wrong proportion there. It's a over 2a, which would give you 1/2 as the final answer. The mirror needs to be 1/2 of your height. Now, we've established in class that this distance right here actually does not matter. We were trying to factor it in. However, Ms. Bouget told us that your size does not change as you move away and from the mirror. Your real size, not like how you look in the mirror, but your real size does not change. So because of that, the distance you are from the mirror actually does not matter. And we've tested it in class. We stood really close to the mirror and we stood really far away from the mirror, and we were still able to see our entire image, as long as the mirror covered at least half our height. So that's the problem, guys. Solved 1/2 of your size. Pretty awesome, isn't it? So thank you for watching, and Justin, signing out.